This podcast is presented by HANNOVER MESSE, your leading event for industrial AI.
Hi there, and welcome to a new episode of the Industrial AI Podcast. My name is Peter Seeberg, and my guest today is, once more, Stefan Suwelack. He's the CEO, co-founder of Renumics. They are based in Karlsruhe in Germany. And our topic today is going to be RAG, the acronym for Retrieval Augmented Generation in an Industrial Setting. Good morning. Hello, Stefan.
Good morning, Peter. Thanks a lot for having me. It's a pleasure to be here.
Yeah, this is your second time, right? I look back at our actually updated website for those of you listeners who haven't been there. If you're ever going to be interested and maybe you want to look back, I think this is now number, what is it? I need to look here. Is it number 234, I think? It was podcast number 190. That's maybe roughly a year ago. And at that time, you talked about Data Centric AI and why that is so important for industrial AI. Now, I assume that you're still dealing with data-centric AI and that is still important, right? But we're not going to discuss it today.
Yeah, it's still important. I think it's still a very valid paradigm. And actually, I think when we will talk a little bit more about the details of RAG later on, I think we will also find that, again, like data quality typically matters more than if you're using GPT-4 or Claude Anthropic or Mistral Large or whatever. But on LinkedIn, more people talking about the models than about the concrete data stuff. So I think this is still a very relevant aspect.
Very good. Yeah, and as I suggested, this wasn't the problem, but you couldn't really search on our website. So today, for those of you listeners, if you want to go back, you can search if you are interested in this specific topic that Stefan talked about. And I think we talked about it a couple of times, just as an example. So you can search now for Data Centric, and then you'll get all the podcasts that we talked about that specific topic, which we're not talking about today. In the meantime, you and I met in Frankfurt also, Stefan, January. That was the HANNOVER MESSE conference, Industrial AI. You were one of the presenters. I was one of the moderators. And, well, you're just a very active person in Industrial AI. You're doing many things. Listeners can learn a lot from you. But to start with, for those listeners that have not yet heard you, please introduce yourself. Tell us what it is that you do and what you do at Renumics specifically.
Yeah, I'm an engineer by training. My PhD was in biomedical engineering, and there was also where I got like my first start in machine learning. And since 2017, actually, at Renumics, we've been building machine learning-based solutions for engineers in product development and in manufacturing for different industries. And typical areas where we're involved in is product development, but also testing is a big topic for us.
Okay, maybe we come to your company, your environment, your colleagues, the tools and stuff like that, maybe at the end for those listeners that want to know a little bit more. But now, for the moment, we're going to go into the topic for today. Is it RAG, I guess, as an acronym you call it, Retrieval Augmented Generation, in typically an industrial setting, as you just mentioned. That's where you work in, that's what our podcast is. So, and then as we quickly chatted, we're probably going to talk about Gen AI engineering. One other topic that you suggested, advanced data analysis. I love that as well. And then we'll see, maybe we'll talk about your industrial AI canvas and a little bit about where are we standing with time series as far as transformers or other models are concerned, and whatever has happened in the last 24 hours, because so many things happen. Always feel free to bring them in. So What is then RAG? What is retrieval augmented generation, Stefan?
Yeah, I think maybe I can start with like what benefits has RAG. Many of us, I think, have already tried ChatGPT, and what a chatbot is, I think everybody is quite familiar with. And I think most people are also quite familiar with the shortcomings of a traditional chatbot that runs directly on a large language model. And that is, first of all, you can't use it directly on your own data. You have to fine tune the model to include more current data or special data. And that is super expensive. I think OpenAI charges about 2 million euros or so per fine tuning. You can possibly do it a little bit cheaper, but still it's like a huge undertaking, expertise. So it's expensive. Most use cases are not worth it. With RAG, you can directly use this technology on your data. That's the first main important aspect. And the second important aspect, we all know that large language models tend to hallucinate. And this obviously is a big problem, especially in industrial AI. With RAG, you can combat these hallucinations, not completely, but quite effectively. So this, I think basically RAG enables you to build systems and also chatbots that run on your own data and hallucinate less. And then the question is, I think, how does it work?
Exactly. That was going to be my next question. I think I have a base understanding, but please tell us, how does that then work?
Yeah, sure. So RAG basically is a two-step process. First, you look for information in your company's knowledge base, so to speak. And this information can be documents, but it can also be like information that is in databases. And in a first step, what you do is you generate typically an embedding from your query to the system. And with this embedding, you look for relevant information, for example, relevant pages in documents. And then you retrieve some of them, hence the name, retrieval. And then you say to the large language model, okay, here I retrieved these 20 documents. Please answer the query based on these retrieved pages I give you. And the large language model then summarizes these retrieved chunks. That hence retrieval augmented generation. So we generate the answer and we enhance the context for this purpose with the retrieved documents.
Can you say that typically when we talk about language models, let's say the foundation model and or, at some point in time we'll talk about, and you and I and we at our conferences have been talking a number of times about, for example, industrial foundation models, but let's stick to the general foundation model. Billions of documents have been grabbed from the internet, typically many other sources, and out comes a foundation model. And you just said, if you want to fine-tune that, we'll come to that later, that costs you a fortune. But should we then think of, so I have a billion documents and result is a model, and now I'm going to add whatever, 20 or 100 or maybe 500 documents of my company, so is it almost like an extension? I tell the model, keep your information, keep your knowledge of the foundation model, but I'm going to give you some additional information that you should look into.
Yes, definitely. I think you can definitely see it this way. And again, I think you can also see it this way in like both steps of the process. Again, the first step is this retrieval. It's basically a search, right? Enterprise search also has been around for a very long time. And what you could do, and you can actually do in RAG systems, sometimes makes sense to just search for keywords, but often keyword search does not bring up relevant results. But by using an embedding from a large language model, all what you talked about, that like the general knowledge of the model, how different terms relate and different topics clusters are basically reflected in the embedding. And this helps to bring up more relevant search results in the retrieval phase. And then when we go to the like summarization phase, again, because the model, for example, understands how to read simple tables, you can actually just put down a table in Markdown format and can ask questions about the table, and the model can extract this information and formulate, and this is where the generative aspect in, formulate a concise answer on this.
Now, before I'm going to ask you to share some general and then maybe more specific industrial use cases, two terms that I would like you to clarify. You just mentioned the term embedding. I think that's a very specific, important, not too detailed, but please tell us. And I'm going to bring a second one in, or a second question, really. Maybe it's related, maybe not. Because you said the data that we provide for RAG, can be, I think you didn't say, but can be any data, PDF files or other ones. Or you said a database. So can it be any, the typical from the past SQL databases, or do they have to be the relatively new vector databases? And does that relate to the terminology embedding?
Yeah, thanks a lot. I think it's super important to clarify the word embedding for listeners who are not really familiar with that. And I also think there's a lot to unpack in the question. So I start with embedding. When we have neural networks, then the network has, or from the network, if you basically, I would say, like cut it in half or cut the network architecture at some layer, what you can do is for an input sample, which can be an image, or it can be like just a chunk of text, for example, or can be audio signal. So for this input sample, you can generate a vector. And this vector, it's just some numbers, 1025 numbers, for example. And this vector represents the input sample in the sense that embeddings for input samples that are similar are close together. So if we have images and we have very similar images, you will find that in this embedding space, they're close together. And they are clustered in a meaningful way. So for example, if you have sports cars, they are more clustered than SUVs. And if you have cars, they're more clustered than trucks, something like this. So it's really semantically meaningful. And with a neural network technology, you can extract this from basically any data type. And this is very generally, I think, one of the most powerful aspects of neural networks in general. And now you can use this to search for information, because you can just say, okay, I have a query. Maybe you have a car and you would like to know, how can I change the settings of my air conditioning? And you have a manual and it's like 200 pages long. Then you can put the query, okay, how do I change the settings of the air conditioning? And in the system, you generate an embedding. And what you also do is you take this manual that is 200 pages long, and for every 10 sentences, for example, you generate an embedding, and then you just look for the passage in the manual that is most similar to the embedding of your query. And this is a simple vector search. And the databases that support these are the vector databases. You have this vector, which is the embedding, and you have the result, and it maps to the nearest results.
So any listener, any company interested in RAG, wanting to provide the upfront information, company information that needs to be available or needs to be made available then in a vector base that cannot continue to sit in a whatever kind of other type of database as it is typically today.
No, that's actually very important to clarify that. So the vector base you typically use when you're dealing with documents. And the way you do it is you chunk up the document into different sections. And for each section, you generate an embedding, put it in the database. And now you have a very simple but super powerful way of querying relevant chunks for your system. This is how you deal with structured text data. But if you have classical data in a database, or maybe even like in an Excel file, this type of embedding works really poorly. So for example, if you have large tables in documents, then you typically run into some troubles. And for example, just to give a reference, there was a study on financial data where they actually used this simple RAG, and it performed quite poorly because it was not properly understanding the tables. And the way way, in our view, and we think it's a very important topic, and maybe we'll talk a little bit about this in this advanced data analysis. The way you do it with structured data is the large language model is able to actually write a classical SQL query to a classical SQL database. And this works actually also pretty well because there's a lot of training data available for SQL.
Very good. Thank you for clarifying. And by doing that, you kind of already indirectly gave us a use case. I thought it was very good. I was following your thought process exactly of, typically having, whatever, a new car is a good example. And for that reason, of course, it's always up to you, dear listener, to apply whatever it is that you hear, if it is not specifically industrial, to think in your industrial. So, you just bought a machine and it arrived and, there it's standing and wonderful, beautiful. And now you want to know, your example was, what was it? Forgot, but it had to do with the car air conditioning.
It's probably a poor example. Yeah.
But it's
that's
okay.
Quite easy, but yeah.
No, but I think that's perfectly okay. That's all our job. That's of every listener. If we talk general, then, each of you can think about it. So, and then you want to know, how do I control whatever, the oil pressure of this machine? And I assume that's exactly the same idea, right? Maybe the machines come with a manual, electronically, doesn't matter. But that's the request. Can you share, maybe this is one, general use cases of RAG, and then maybe move into the industrial space as well?
Yeah, sure. So I think generally I found that most people can actually relate their use cases quite well to this technology. Because when we talk about RAG, what we always say is, okay, let's imagine you have an assistant that can answer any question on your documents and your data. And this is, from my experience, like a much better mental model for people than the previous, I'd say, machine learning model, which was, think about your processes. Where can you automate something that runs on unstructured data, right? And the people are like, okay, I don't know. But like having this assistant in mind really helps. And then when we look, okay, which questions do I want to have answered on my documents? Then I think these use cases I just mentioned, you have a big manual and you would like to answer a question, is something that comes to mind first. And it's already provides a lot of value, especially if you manufacture complex equipment, right? Then, and you provide this to your users, then not only your users can like deal with the machines faster or can install it faster, can troubleshoot it faster. But as a manufacturer, you will learn a lot about the questions people are actually asking. So I think this is a super important aspect. And this is why I think every like machine manufacturer should have such an assistant. But there are other use cases, obviously, industrial areas. Every time we deal with documents, when you're writing an offer, you look up maybe, have we done something similar in the past? Okay, I have to write this way. You can assist this. Anytime you troubleshoot something, right, you might have a big database of tickets. Obviously, it's pretty straightforward to use it. And then you can like run into like more, I would say, like specified use cases where you have processes where you're dealing with document types of data, and you can help assist this and automate this. And maybe the last thing towards the use cases, our experience is that it's really good to start with a use case that a lot of people in the company can use. So I think it's better to prioritize a use case that's popular versus one that brings the most business benefit in terms of automation or so, just to get this into the organization very quickly, because then people will come up with like more ideas on how to use it and where to use it.
Interesting point. Yeah, I've been giving these workshops, I guess. And yeah, typically what I do with a group of people is exactly along those same lines, talk for hours about use cases, general use cases, and then concentrate, each of the attendees concentrating on their own environment. And in the end, it's like a one-day activity. In the end, I expect him to themselves come up with the criteria, and you just add it, or you provide one criterion. Number one is always, do I have data, etc., etc. If I don't have data, I can't do anything. But that's a very good one. I like a lot your mental model. Yes, I use that as well. So you relate. Today we talk about assistants. Maybe we talk about co-pilots. Although that's already, I'm not sure if it's a copyrighted term by Microsoft in this case, but the idea of a person sitting next to you, like in this case the co-pilot, or can be any assistant. I like that a lot. A new thought that you related to the past machine learning. Now, one specific question, and maybe then we do come to that later. So whatever I want to know, kind of, that is written down. Now, that's where my question I was going to come from, because does that mean that the typical, and you related it to, the machine learning of the last, 5-10 years, and in those first 5 years, the number one use case has always been like predictive maintenance, and predictive maintenance was typically machine learning on top of time series. So is that maybe for the same reason not the typical use case for RAG, but maybe another one, I don't know, that we can still talk about later when we talk about time series data?
Yeah, I think in RAG, if you look at, I would say, like more like the basic RAG version, you're always looking for use cases where you actually have the answer in your data or your documents, but it's just a lot of work to find the right passage and then to summarize it. And I think this is also in a way much more easy also for like other stakeholders to understand if the problem is solvable with RAG. Because with predictive maintenance, right, you have this, okay, I have a lot of signals. Can I predict the future? I don't know. Maybe you can say, okay, a human would be able to predict this. Then it should be possible for the machine as well. Things like this. But you never really know for sure. And obviously in RAG, you have to try it. But I think you can develop a good feeling what will work on RAG and what probably is way out of scope quite quickly. And I think this is a very important point.
Okay, very good. Yeah, I like that. Still, probably if we have time, I do want to come back to the time series at the end. But it's a very nice classification. So RAG is like, the answer is somewhere there. It's just going to take me as a human maybe 10 minutes or maybe a day. And using RAG, I can get it quickly. The thought you gave me was like, I sit in my car and the yellow light goes on for, I think it's called AdBlue. Is that how it's called globally? I don't know.
Yeah.
And there's this weird sign. And the last time it happened to me, and the car is not used, 20, 30,000 kilometers. So I've seen and then I started looking in the manual and I was afraid that something really, really bad was wrong. But it took like a long time. So I think it's a good example of, in this case, in the car. And of course, in the industrial environment, it's very similar. Now, you mentioned already fine tuning. So what does that mean then to number one, fine tuning is expensive. Maybe fine-tuning was there before RAG. I don't know how old RAG is. What does that mean then? As you said, it's so expensive. So is there still a use case for fine-tuning, or is fine-tuning for that reason then that?
Yeah, I think it's a super important question. And the short answer is, in my opinion, fine-tuning is super important and will become more important in the future. And in a RAG system, we will have both. We will have like the RAG mechanism and we will have fine-tuning. And I can explain a little bit why I think that is. So the first thing you mentioned, cost. Obviously, and I mentioned it, fine-tuning is expensive. But RAG can be expensive as well. So, I mean, the way it works is you retrieve these documents and then you put all the retrieved documents in the context of the model. And then you say, okay, please answer based on your context. And as probably most listeners know, that the pricing for these models goes by tokens. So if you have a large context, your query will become very expensive, and also it will become the latency will rise. So if you do on GPT-4, like the maximum context reg, it costs, I think, about 50 cents or so per query, which is ridiculously expensive, right? So what you want to do is you want to have only a few retrieved documents. And this means that your model has to understand quite well, like the context and all the specifics of your domain. So if you have a model that is in a way a little bit more fine-tuned to your domain, this helps in the retrieval and also in the summarization. And also in industrial AI settings, what we typically have, that we have like specific terms, like a glossary for a domain or a company even, and you have to teach that to the model. And one way to do it is just put it in the prompt, right? You just say, okay, use this term, or this means that, this means that. And this works actually quite well if you have like just a reasonable number of terms and so on. For one application, this works. But if you're looking like a whole organization, I think it totally makes sense to, in the future, have like fine-tuned models. I mean, Bosch, for example, I mean, they are already talking about this, how they did this, have like the Bosch GPT, for example. And then there's a lot of like the typical Bosch terminology and knowledge is in the model. And then you can still do like RAG with that model. So I think you need both fine-tuning and RAG.
You mentioned Bosch. That's a good example. So if it's Bosch or Siemens or any of our hidden champions nobody has heard of, but if you're in the market, they're the $2, $3, $4, $5 billion companies. So any of those companies, I can. Although, as you say, it's expensive. I mean, you need to look at what do I get out? What do I need to put in? But you and I, together with the attendees of our conferences, have been talking about the need for, in this case specifically, industrial foundation models. So, and I think the last conclusion we had, sure, for the big companies, as we mentioned, it's relatively easy and they have budget to do things like that. And would that then be closed? And we're moving into open source soon as well. Would that then be closed? Closed Bosch, closed Siemens, closed Festool? And or, is there still a need for foundation models, a general industry? Or then I think of now OPC UA, you have information models, and like the German, VDMA, I think they have like, they categorize the industry in like, 30 different segments, robots, NC. So if there is an organization that is interested in NC machinery, could they maybe, if they have it from their members, take the money and say, now we are going to make an NC foundation model, or like in this case, a fine-tuned model?
Yeah, I think so. And I think it's super important that we talk about this. And I also think that there are currently some like base open source LLMs that where fine-tuning is not too complicated, I would say. So I think going like first steps in this direction is actually, just from the technical perspective, not so difficult. But I don't want to blame anything, and I can totally understand it. But I think like still data sharing is such a big problem in Germany. And I think still I'm not aware like of any big, great project or collaboration where this is done on a slightly larger scale. The most projects, and we are involved in like different and research projects, it's always when it comes to the data, people are currently we can only use that, and this is a big problem, because I think the companies are missing out on amazing opportunities, first of all, but second of all, for example, let's take vision data, right, where it would be interesting to have a foundational model for quality control in computer vision. And I think the way it's going to play out is there will be a US-based supplier of this equipment, and in their terms of service, they will say, okay, we can use your data. And in the beginning, people will say, oh, no, we don't use it. But then everybody's using it. They will have all the data. They are training their models, and nobody can touch it. So I think the much better strategy for typical, as you said, hidden champion manufacturing companies would be to see, okay, which kind of data and knowledge that we have that is like a little bit more general, could we pool into a foundation model in collaboration with others, as you said, for example, for machining, for testing data, for all kinds of things. I think that would be immensely valuable.
Yeah, it's a huge topic which we will continue to discuss. And whoever of you, dear listener, have a solution, please let us know. Well, we're going to continue to discuss it. So now we talked tools already. So do any tools, open source or other, exist for RAG, and or maybe you suggested even for fine tuning as well? And if so, which of those could you recommend?
Yeah, maybe I start with the RAG tooling. It's amazing. I think RAG tooling started to explode in spring 2023. And the first project that maybe most listeners are familiar is LangChain. Everybody uses LangChain. And I think it was the fastest growing project on GitHub of all time. We used it for the first test as well. And it's it integrates a lot of things. Basically, in a couple of hours, you have a basic working system. But it's or we feel, and I think most people feel that way, it's not production ready. It's good to build a demo, but it's super hard to debug and a lot of things are breaking and so on and so forth. And so that was the first iteration. And I think the next iteration was a project called Llama Index, which focused a little bit more on RAG and did some things differently, which was a little bit better. And now...
So Llama is Meta, right? Or behind, is that right?
Sorry. Yeah. So the project, I think, is still called Llama Index. Yeah. I think it's probably the term originated from the Llama model from Meta, but it's completely independent. It's just a RAG library that works with basically any LLM. Yeah. And then I think this was, I would say, in autumn last year, where most people are doing still this vanilla RAG that I explained. And now I think everybody understood that getting to a working system is really, really easy, but then tuning your data is selecting the right search and ranking mechanisms and the right query routing and so on and so forth. So there are a lot of details that matter when you do these things. And there are now other frameworks popping up. I think Dancer is one of them that have better re-ranking, for example. And so I would say it's a month-to-month thing where they develop on both on the method side, but also on tooling for how to bring it into production. Obviously, observability is a big topic. How can I understand if the models are doing the right things? My colleague actually just wrote a blog post about how you can evaluate this. He used, I think, a small project called Ragas and our Spotlight project. And I think, again, this was just a couple of weeks old or so. So it's moving incredibly fast.
Yeah, as I suggested at the beginning, whatever has happened in the last 24 hours.
Yes, exactly. Absolutely.
Maybe we'll talk about building RAG-based assistants for industrial applications in a moment. But one topic you had suggested, and I love to talk about as well, and maybe it fits right in here, is advanced data analysis. So how do you see that capability? I think in this case, the terminology is from OpenAI. It was called differently. I forgot already. But how do you see this technology, this approach?
Yeah, I think it's super interesting for industrial AI, and it might be, I think it's still early, but that this might be one of the killer use cases for RAG or Gen AI in industrial AI. And why is this? So in the past, I think companies had invested quite a lot of money to get data back from their machines. And this can be a fleet of cars or trucks. This can be a highly complex machine in a factory. And now we have a lot of data about different operations, and where we could understand when a car does a phantom braking on the Autobahn, what happened, right? For example, or when a machine malfunctions, what happens. But the reality currently is that this data is typically quite inaccessible. In the best case scenario, you have it on the cloud and you can query it. And then you have data scientists building dashboards to aggregate some information on the data. But then you always have, the engineers cannot directly access it, right? They have these data experts who build dashboards for them. Then they look at the dashboards. Okay. But they don't have direct access to the data. And actually getting the data to a state where you can query it is also difficult because typically, first of all, your data is messy and you have to organize it in a way with like data catalogs. You have to describe it, you have to clean it. And this is also a very expensive process at the moment. So typically a lot of the data you have, it's somewhere like in this data lake or data swamp, and it isn't even queryable. And there, this Gen AI can help because Gen AI can actually access the database directly. So instead of having a data analyst who write a Power BI or Tableau dashboard, the engineer can directly say, okay, I want to know where did my suspension bottom out, right? Or so. And then you in the last couple of days or for the specific vehicle or whatever, right? And then you can retrieve the data, you get it back, and the AI can also prepare a visualization on that. And then you go from having to have like days or even longer to get your answer to an immediate answer. And you really bridge that gap. I think we talked about it as well. I think what we've talking about for years, this gap between like the domain expert and the data scientist, right? And I think this can help. And this can also help when you clean the data or when you write data catalogs, because to build a great data catalog, you have to know the machine. You have to know, okay, this happened there. Okay, this sensor signal. We switched the sensor there, all these kind of things. And when you have direct access to the data, you can do it yourself. You can do it quickly versus you have to do it with other people very slowly.
Well, the topic is then spot on with, what's his name? The NVIDIA guy CEO a week ago saying, you don't need to have children learn coding. And we had this topic many, many times. Please, the listener, do not take it personal. If you want to code, please code. But it is all about, and I had the same topic a couple of months back, Machine Learning Week Europe. In Berlin, I did a workshop. There was 3 people, and 1 or 2 of them were actually data scientists. They didn't like it at all. So it's always going to be, it's the same. It doesn't matter if it's about coding, can I use, is that then the Microsoft Copilot, I guess? Or if I'm a data scientist, I'm a strong believer in, AI, whatever we call it, RAG, large language models. You're not going to lose your job against another person doing similar things as you, but you're going to lose it to the person who will be using these tools if you are not. That's what I'm completely convinced of. And I've been using this advanced data analysis myself, and I'm not a data scientist. So I'm almost like, that's towards the domain expert, which I'm also not, I guess. But I can use it. I can say, look at this CSV file here, and please do some analysis on it. It's amazing what it's capable of doing. And then if you're a data scientist, you can do even more, I guess, or it can do the base work for you. And if you're a domain expert, you get, as you suggested, you can do things maybe without needing to wait for your colleague data scientist.
Absolutely. And I think what will happen I think that you can make more decision based on the data, which currently, if you're designing a new machine generation, right, then you have like a product owner, maybe who says, okay, we should keep in this component, or should we support like very heavy parts, for example, or not? And then they talk to their customers, they have a feeling, and they make a decision. But when you have data, you can say, okay, well, I just look into the data, how many heavy parts were handled by my machine from these and these customers. And just one example, right? And I think still in many cases, it's not done this way currently because the costs are too high and it takes too long. And when we make it quicker, data will become much more important than it is today. And I think this will ultimately also be good for all data scientists. So I think
I would agree. Yeah.
Nobody has to be afraid of losing their jobs. I think everybody's also telling me, no, they want this, they want this. We have like still these and these dashboards to do and so on. I think probably a lot of them are quite happy.
Yeah, exactly. It's the type of work that will change, I'm convinced. Yeah. I'm convinced that of 100 coders who have been doing doing. And coders are the same as, in this case, data scientists. Different job, and the topic is exactly the same. Of the 100 jobs that were, let's say, front-end jobs, they're going to be, taken over for a big part. Maybe 50, 60, 70 of them are going to be taken. So the easy ones are going to be taken over by the tools. So the domain expert using the tool, doing things by him or herself. And I think implicitly, those people are going to continue. And I can very well imagine that we're going to need more people. We're going to need more coders or more data scientists, could be, I don't know. And then it's the topic of, do children, young people need to learn that or not? I am a supporter of showing them more the high level stuff. But we're going to need, of course, the background infrastructure. We're going to need probably more, work to be done. So that the front end can function. That's my personal belief there.
Yes, and especially I think if you go to the higher level aspects of the system, for example, system architecture, then you definitely have to know what you're doing. And I think at least the current generation of tools is not capable of doing that on their own. And I think to have this basic knowledge, to know what you're doing, is still super important. And one thing, when I think about nobody has to learn to code anymore, I'm not convinced by it, because I think you have to know some basics to understand the slightly higher level stuff very well. And if you don't understand anything, then you will probably produce a lot of rubbish at these systems. So I think actually it might become a relevant problem. But for example, I see it in our team, I see it in other teams, people who are very good at building systems and have done a lot of coding in the past. Now they can do the work maybe twice as fast, I would say. But how about the new people that had never learned the basics? Will they also be able to do it twice as fast? Or is it just for the people who are already underwent this kind of training? I'm not sure. So this can be, I think it will be a tricky question to be answered in the future.
We'll find out. We have 2-3 other questions. One is then, how do we build rack-based assistants for industrial applications? And what role, if you want to share that, you have a thing called, I believe, Industrial AI Canvas. What is a canvas, and how can that maybe at the basis help listeners to build these rack-based assistants?
Yeah, I'd be happy to. So when we did we had finished the first couple of machine learning projects, we obviously realized that there are always similar things that you have to take care of and that you make sure are correct. And if you forget them, your project will fail. And so what we kind of need is a kind of template, I would say, in a first thing, or a checklist, and to make sure your project will work out, and to build a great concept for the project. And obviously, just a checklist, for example, I think is very unsexy and not very visual, not very collaborative. And there is a framework based on canvases. I think it was popularized by Alexander Osterwalder in the business model canvas or the value proposition canvas. I guess many listeners have at least seen this. And the way it works, it's basically a large blank sheet of paper, like in a poster size, and you have different, it's a template where you have different areas. In the business model, you might have an area where are your customer segments, what's your value proposition, what are your distribution channels, and so on and so forth. And how you work with this canvas, this big sheet of paper, is you have your areas that are kind of the things in the template you should take care of. And then you put on Post-it notes how you're going to do this exactly. You can do it obviously on a table. You can also do it digitally. And in this way, it supports a very collaborative workflow and also a very iterative workflow, because in business model generation, you make a first draft, then you have a hypothesis about maybe a customer that have a need, then you test it, and then you change it. And the way it is, it's very similar in machine learning. It's collaborative. You have a lot of stakeholders. You have the domain experts, the IT experts, maybe legal even, right? And you have some hypothesis, for example, this data source is available, or we can integrate into this application this way, or we can use the data and there's no data protection law in place, whatever, right? And again, a very a topic that has to be done iteratively, collaboratively. And this is why we feel this Canvas strategy or this Canvas method is a super good fit for conceptualizing generally machine learning systems.
I did one. I think it was 10 years ago. Industrial data analytics, a startup at Softing. I'm not going to share the details, but I have it in front of me here. And there was a value proposition, and it was for a product or service called on-site stream analytics 10 years ago. And the way that I looked at it was like I did work for a long time, company Intel, and every company has their own way of doing things. But since then, I cannot do any project without first having exactly in my brain who is my target audience, what is my objective, something like that. And I think the Canvas is very similar with, as you said, these maybe 10 different groups. Now, you did an industrial AI Canvas. Is that available for listeners to be downloaded? Do you provide service consulting in filling that out? Or?
Yes, sure. So I think there's a blog of ours on the webpage. You can also just Google Industrial AI Canvas. You will find it. You can download the PDF. We're also currently working on a new version or the new site for the website where there's a little bit more information also like on the Canvas and how to use it. And from our experience, you can just download it and play around with it and get a little bit of a start for yourself. But we also experienced, and I think this would be the biggest drawback, I think, of the Canvas, that it's not so easy to actually fill out the complete Canvas. And we thought about it a lot. And I think the biggest problem is that the goal of the Canvas is to bring all the stakeholders together, right? IT, domain experts, data scientists, and the different categories in the template, right, are really deep, and we are proud of it. It really dives into how does the UI look like. It really dives into what kind of model do I need? What data sources do I have? And that means you actually need the expertise of the different stakeholders to completely fill it out. There are very few people who can do it like just by themselves. And and this is actually where we do consulting, and we're bringing together these groups of people and conceptualize machine learning use cases. And this is always, for me, a super cool job, super cool experience, because typically there are a lot of people from like different departments. Sometimes they come together like for the first time to discuss this topic, and there are a lot of people with like great ideas. So it's like really bubbling. And then we can say, okay, now having the ideas is often anyhow not the problem. It's then organizing these ideas, putting these into a canvas. And what we do is, or what the ultimate goal of the canvas is, to actually have, as you said, most important thing, value proposition. And then you go through all the technical steps with like highly in depth. And then you end up with how much resources do I need to make this happen? And then you can go to your decision maker and say, okay, we think we have this value and we have this effort. Let's go.
Good. I need to cut you here because we have 8-9 minutes. We can go long. I already have a very bad name with Robert. I think that I go beyond the 1 hour. So, and I have 2 more topics.
Yeah, sure.
I do want you maybe 2 minutes, 3 minutes per topic. So the one that we had was generative Gen AI in engineering. The other one, I do still want to know from you about time series. We talked about it today. So what is your perspective then on, it's called Sora, I believe, right? Not SOTA, and the role it may play in industrial engineering?
Yeah, I think it's super interesting. I think at the moment, it's probably like pure research topic, and maybe even a bit philosophical. But yeah, I really love to think about these things. And yeah, when I also looked at Sora, I was amazed. There's this scene where like there are some pirate ships dancing in a cup of coffee on the water, right? And there's a lot of physics going on there. The flags are waving in the wind, and the ships are on the water, and the water is forming foam and stuff like this. So, and this just from a prompt. So I think implicitly there's a lot going on there. You have to have the knowledge about the 3D scene. You have knowledge about the physics and so on and so forth. And I really think that in a very basic, error-prone, implicit way, there is a lot of like the engineering workflow in a nutshell, or in a cup of coffee in this case. And I think it's fascinating how well it works. And and I think it will show that there are some things that are possible to be used in the future of engineering.
Right. And again, I come back now to these, the conferences that we did. And I think one of our attendees was suggesting, not specifically in this, was it like a brainstorm, as an engineer, as a design engineer, just by telling the model, telling the app, the Sora app in this case, or any others I haven't seen yet, just tell them, in whatever words you have for a thought that you have. And, a minute later, you see it and you get visualized in front of you. It's a complete new, I would think, complete new way of, coming to ideas for whatever, future products or services you will be generating, right?
Yeah, I think so too. Although I also think traditionally, these models obviously are kind of interpolate what they've already seen, right? In a sense. So coming up with a complete new design might be difficult, but I think it's also a philosophical question. You could also argue most new designs are somehow interpolations between different things that were already seen, right?
Most certainly, yeah. But it's a difficult topic. I mean, we're not talking art here. I mean, there will be some artists listening in, but I'm completely convinced. Have you seen these wonderful engineering images by Leonardo da Vinci?
Yeah.
How old are they? Are they 400? No, they must be older. Maybe was it Renaissance? Is that 500 years old? Does that mean that we're not allowed to make any of the beautiful, wonderful constructions that he, and maybe there have been many, many other people before him, but I just think of him. And that's the same with art or with everything. Now, I'm not saying that that gives the right to OpenAI and all the other companies to just use that. I am not saying that. Let's wait for the judges. I think there's going to be some solution somewhere in the middle at some point in time. It's a complete different, well, not different topic. It's a part of what we're discussing here as well. But nevertheless, I do believe that even if you call it interpolating, I think it's amazing for the individual engineer using the tool, and the tool which has been fed with billions of imageries. The individual has never been able to see a billion ideas, right? I think you then still are going to end up with, for you as an individual, new ideas.
Absolutely. I totally agree with that. And again, I think there are also like studies on maybe good ideas and bad ideas, and there's definitely like also like a systematic how to generate good ideas, and they often revolve around like taking concepts from different domains and mixing them up, which is also I think a kind of interpolation. So yeah, I totally agree, and I would also agree that the scenario sketched out where you get from an idea to a first result so quickly, I think this will change a lot. I think this will just fundamentally change the processes, because you can iterate so much faster. And even if it's not like super 100% correct and so on and so forth, it's still like a huge gain.
Stefan, closing off our topic of RAG, I still want to know and hear from you. You told us that RAG is typically being used where the answer is available, but it's somewhere available around you, like in hundreds of pages of manual, as a very good example. And RAG today, or it cannot, I understand it can implicitly not be used for what we have been using in the first, I would say 10 years, machine learning, all kind of different wonderful ARIMA, SARIMA as the base ones, and then all the other great terminologies that I must say I've in the meantime almost not forgotten, but they're not being used. Maybe they are. Now the question then is, so what about solutions out of the generative AI, out of the maybe not RAG, but then fine tuning? Where are we maybe with the base technology transformers with regards to time series? I mean, so if I do want to get a feeling for the problem, why is my machine standing still, then typically I believe I have to go to my time series. I have to go back to all my sensors, to all my signals. So what is happening there? I hear there are certain developments, but where are we standing there?
Yeah, so I can give you my perspective or experience from the part that we did a lot of work in, and or my motivation for this topic is that we are doing a lot of work in acoustics, which I would here in this context maybe frame as a high frequency time series. And we found, so this is used, for example, in like testing data, but also in end of line testing, just to give two industrial AI examples. And there we found that transformers work really well. They now outperform a lot of nearly all other methods, and they really benefit from having a pre-training, especially even like training on like everyday town noises, for example, and you can easily fit this to specific machine noises. And what we've done then with high frequency time series, which are not like acoustic per se, you can actually translate it, build a spectrogram or translate, think of it as an audio series and also put it into the transformer. And this works very well. And then in time series, you go like lower and lower frequency. And what you then want to do is you wanted to use the transformer directly on the time series. And there is, as you said, a lot of work in this area. And I really feel that this, what we observed in the like high frequency time series domain, that pre-training helps you to build like very data efficient, reliable models. This will become available for like other time series machine type data as well. But I also think it currently still depends on the application, obviously.
Stefan, we're going to close it off here. 1 hour is just 2 seconds before the hour. Thank you very, very much. We could easily continue. We'll do that in a year again, maybe, and discuss what will then have shown up in the meantime. You, dear listeners, if you want to get in touch with Stefan, I believe the best way to do that is on LinkedIn, Stefan Suwelack, Suwelack. You find his name in the show notes and the podcast notes as well. Thank you very much that you stay with us so far. You can always email me, peter@aipod.de. Looking forward to have you with us again. And Stefan, thank you very much. I hope to meet you soon again, and take care until then.
Thanks a lot for having me. I think we'll meet at least at the HANNOVER MESSE in April, I think. So yeah, very much looking forward to that and really enjoyed it. Thanks a lot.
Thank you, Stefan. Bye-bye.
Bye-bye.